You've probably used the update method to check conditions every frame. But did you know there's a more efficient way? Today, we'll build a reaction time game without using update, and instead, leverage event-driven logic. Let's go. Here's a simple reaction game. A button appears after a random time, and when clicked, it records your reaction time. To display the button, you need to calculate the time passed. Using the update function would be the first thought for most developers. The code using update constantly checks if enough time has passed. But update runs every frame, meaning unnecessary checks, even when nothing changes. Now, let's improve this using events. Now, instead of running checks constantly, our code schedules the button to appear at a specific time using async await. We've also subscribed methods to handle when the button appears and when it's clicked. No wasted CPU cycles. Just efficient event-driven logic. Let's compare. On the right, update is checking every frame. On the left, our event-driven approach only triggers when needed. In a small project, the CPU difference is negligible, but in larger games, constant checks add up. Performance aside, event-driven code is also cleaner and easier to maintain. With update, logic is scattered and harder to debug. Events let us separate logic clearly, making the project more scalable. As you can see in the case of script with update, we also need a bool to check if the button is active. Both approaches give the same result, but event-driven logic makes the code more structured, reduces unnecessary checks, and is easier to extend in larger games. Now let's get on to building the game. Here's how the script works. We start by declaring a button and a TextMesh Pro text field to display the reaction time. Let's also add a static event just in case we want to do something when the button appears. When the game starts, we hide the button and subscribe a method to our event. This ensures that when the button appears, we get notified and can respond accordingly. Instead of using update, we use async await to schedule when the button should appear. Once the delay ends, the button appears, and we store the time to measure reaction speed. First, we need an empty game object to hold our script. In the hierarchy, right-click and select Create Empty. Name it Reaction Game and attach our Reaction Game script to it. Next, we need two UI elements, a button and a text field. With our UI elements in place, let's connect them to our script. Let's also assign the OnButtonClicked function to the button's onClick event. That's it. Press play, and now the game randomly shows the button. Click as fast as you can when it appears, and your reaction time is displayed. With just a few quick steps, we created a fully functional reaction time game. No update loop, no performance drain. Now, go ahead and test your reaction speed.